Traditional business intelligence, analytics, and tools only create islands of visibility. Finance, sales, procurement, fulfillment all have their own cubes. And even if the entire enterprise works off one data platform, those cubes aggregate data for a single perspective. They're good at telling users what happened, but again, only within that one silo. Maxa.ai has a richer way of modeling the business processes that make it possible to answer what happened, why, what's likely, and even a bit of what should be done, but across perspectives. And with this in place, you can now reliably talk to your data with an LLM in production. This is talking to your data done right. So here to tell us how this works are Alexis and Raphael Steinman of Maxa.ai, both co-CEOs. Guys, welcome, and thanks for joining.
A pleasure to be here.
So let's jump in and show folks right away how business intelligence tools can be reimagined to have a richer perspective and to enable a narrative interaction with data.
Great. Actually, maybe before we start showing a bit of Maxa, it's good to reframe who we're talking to. So typically at Maxa, we are trying to service people in finance or people that have a behavior, a need for consuming data that's very similar to folks in finance. So if you think of in your environment, you have lawyers, management consultants, doctors, software developers. They're all using a ChatGPT-like tool now that has profoundly changed their profession. And when you go in companies, talking to people in finance and other folks that run their business using systems of record, so large databases full of numbers, there is no such transformation, no such sort of miraculous tool that has landed on their desk 18 months ago. So the goal with Maxa is to be able to extend the reach of large language models to environments that are not language, documents, a software code, but actually databases with huge numbers of rows and records and numbers, and to extend the power of those large language models, preserve their full reasoning capability, which is really the most amazing part of what they're able to do today, and also provide a sort of a backup and a support mechanism that's very consistent to what these teams have been using forever, including, for example, downloading to Excel, so that you can actually go and prove when you need an answer to a question needs to be 100% correct. So that's kind of the frame around what we do. Any questions from you, George, before we show you a bit of eye candy?
No, that was a good framing, which is we have a new user interface. Now we have to rethink how we're going to serve, in this case, data through that user interface.
Correct. All right, so I will fire up our demo environment and hope that the demo gods are with us today. So before we start asking any concrete question, maybe sort of a trick question, we will ask Maxa what it knows about this business. If you remember, when we're dealing about enterprise databases, systems of record, they are secure, they are private. Language models have not been trained on this data, so they're sort of coming in blind. They haven't never heard about this business or the underlying data. And in a fraction of a second, you need to fire them up so that they fully understand the business. So we would ask a question such as, provide a detailed overview of this business and how it operates. We run the system. Typically now we're running at about 30 to 60 seconds to get an answer. And then poof, you can see it has understood pretty much everything you need to know to reason about this company's data. So here we're talking about a comprehensive business overview for a food distribution company, a sophisticated food distribution company specializing in nuts, dried fruits, specialty food items, et cetera, et cetera. And then as you can see, it goes on and on, characterizing the industry focus, the customers, the market position, and then what it actually finds in the data model in terms of customer orders, how it manages inventory, fulfills the products, the warehouses, suppliers, inventory management, et cetera, et cetera. So if you think about humans trying to come up with a summary of this business and how it functions from a data perspective, this is pretty much as good as it gets in terms of providing a high-level overview. So we were running this question just to show in a fraction of a second, the system can fully understand what's going on in the business, what are the key components from a data perspective. Then we have three other real questions that we've prepared. So the other question would be, the next one would be, for 2024, list the top 20 customers by sales, provide their profitability both from a percentage and dollars perspective, and then include any other relevant information you have in your summary. The goal here is to show that you can quickly power through millions of records, generate extremely clear tables, charts, and summaries. And this will show, for example, that this food distribution company has its largest customer, Kroger, with $22 million in sales, followed by Costco, et cetera, and you can generate on the fly some interesting charts and summary tables to look at the data. Now we go back to our persona and say, I want to actually investigate this $22 million figure and $19 million for Kroger and Costco. I want to be able to access line item records that allow me to prove that this number has been calculated correctly and it's not just coming from an untrusted calculation. So this gives you access to all of the underlying records at line item level, and this gives you sort of a first glimpse into our data model, right? So we are bringing together multiple systems of record, ERP, financial, operations, warehouse management, multiple locations, bringing that together in a single, unified, harmonized data model, and allowing users to download record level detail to be able to reproduce some of the key calculations, in this case dealing with sales, profitability, et cetera. And if all this can be downloaded to Excel, even if there's 300,000 relevant records, you can download all of that locally to perform audit and other comparable purposes. You can ask interesting questions, like if you go down the list of customers, you'll notice that they tend to have a 20 to 30% profitability margin. And then you have some outliers like General Mills that actually has a negative profit margin, or Dollar General that has a very low 6% margin. So you could ask, why is General Mills profit negative? And again, the system runs, and if you sort of follow the explanation here, it gives you sort of all the key elements as to why, from an overhead cost, from returns, from products with low to no margin, why this customer ends up being a negative margin customer. So this would take hours, if not days, to try to figure out on your own, navigating these huge databases. Our second to last question, we're going to start pivoting from questions around just historical calculations, aggregations, and looking at sort of forward-looking or more like why type questions. So the next one would be, based on 2025 data, which product SKUs should I retire and why? So you run the question, and the answers are remarkable, right? It deals with customer products that have severe financial losses, products that have very low levels of transactions, high levels of returns or discounts or other concessions that are made related to those products that have been discontinued in the past, but that are we keep selling, et cetera, and you can consolidate those answers in a very clear table that gives you, the retirement reason by product SKU with all the relevant information that goes with it. Lastly, one of the customers is the pharmacy chain Rite Aid. So we could say, what do you expect total sales to be for customer Rite Aid for the full year 2025, based on year-to-date performance and the performance in the last 2 years? Again, run the question. The system comes out with a projection. Rite Aid should finish the full year 2025 at approximately $900,000 to $950,000. It's taking into consideration historical growth trend of 8.5%, what is obviously done year to date on a monthly perspective, looks for seasonality, computes both the year to date monthly performance, seasonal adjustment, the growth rate from prior years, and then pops out the answer around 900 to 950. With all the obviously all the backup. If you wanted to do a similar test in Excel or throw this to your data scientist, it would be a matter of seconds to pull up the records that have been used to generate this calculation. So as you can see, this allows us to ask black or white questions that need 100% accuracy, for which you need backup and an understanding of both the reasoning and how the calculations have been performed. And it also allows you to ask questions that are a bit more forward-looking, or why, or that have a gray spectrum of potential acceptable answers, as long as you provide backup for the reasoning. and the data inputs and figures inputs have been utilized to generate the answer. So you have really a behavior that's consistent with what finance teams and teams that depend on systems of record, the bars that you have to reach today, and obviously the kind of the workflow and the underlying logic that they've become accustomed to.
Okay, that was a great overview. Now I have a million follow-up questions, but let's start with in analytics, everything is how you model the data. So let's start at that foundation. That what allows you to have this, much richer perspective, even before we layer on the LLM and all the calculation functions. You have to be modeling this data in a way that gives you multiple perspectives. So let's talk through that. Now that we've done the wow, let's do the how.
So I guess the how starts, historically, all systems have been really focused on modeling data relationships and the facts to sort of anchor them with these relationships. But you think in the world of AI, to really unlock the reasoning like Alexis showed, you really need to unlock a lot more than just the facts. There's a lot of business context, how the business operates, so that a little bit like we saw, you just drop the AI on the data and it starts reasoning and figures out what the business is, what industries there are, and starts becoming very precise about its understanding about products, customers, and how it happens over time. So instead of moving from data modeling about relationship and facts, it's a lot more about modeling business context, the business activities, and then all the facts that happen over time. So Maxa, we've created what we call a 4D data model. So essentially, it allows to blend business context, business processes, time, business activities, and dimension facts, and then enrich those with metrics. So when the LLM is dropped on this model, it literally has the whole history of the company, the context, the activity, and more importantly, how the business processes have weaved this data or collected these facts or received this information across time. And that's when you could really sort of unlock the full power reasoning of LLMs.
Okay, so Raphael, before you go too deep on that, let me just ask you to orient things to people who have been brought up with like star schemas and dimensional modeling. And, this is when I was talking about silos when we started, the idea is that to get a columnar database, to provide performance, you're sort of denormalizing and squeezing stuff into these aggregates. And when you do that, you're losing detail, and it's very hard then to ask from another perspective. So explain how your new modeling approach works differently from that star schema that we've all grown up with.
So maybe just let's go back in time. So like, why do star schemas exist? So star schemas exist back in the day when 4 megs of storage cost hundreds, maybe thousands of dollars, and compute was one of these rarest resources that everybody was sort of trying to protect and conserve. So data modeling actually historically dates from the 70s when we were trying to balance. So the existing data modeling is balancing a compromise between compute and storage and trying to get the best of both worlds or compromise between these both worlds because it was just super, super expensive to operate. Now let's fast forward in the age of AI. Storage is infinite, compute is infinite, but we're still modeling the data. We sort of forgot why, or tend to forget why. Why are we still modeling and thinking in star schemas and facts and relationships, and why are we actually still building that way? And it's funny, because when we hire data engineers at Maxa, it's literally part of the onboarding program where there's a little bit of de-education. So we literally tell them, like, you're going to start at Maxa, all your reflexes, your best practices are going to get triggered, and you are going to believe that you were maybe going down the wrong path. So just do the course, stay the path. You will see that at the end, there's something really, really rich that you can model. So this model literally, like an example, we have some customers who have ERPs with over 10,000 tables. So you could see star schemas everywhere, tables everywhere, a lot of facts spread out. We could our model is able to take these 10,000 tables and reduce it to one table, but that table contains 4 dimensions. Like I said earlier, the context, the business activities and processes, the fact dimensions, and has weaved it across time. And with that, you have one table that has everything, but you have all the full richness of the business activity.
So let me see if I can replay and understand the trade-offs, and then you can walk us through the details. This idea of dimensional modeling, the star schemas, came from decades and decades ago, when compute and storage were really scarce and had to be conserved. And so we sort of denormalized and aggregated the data so that it could, with high performance, with a minimal amount of storage and compute resources, essentially answer pre-aggregated questions. And what you're saying now is, no, let's keep all the data, and even if we duplicate some of the data, we flatten it out into like really, really wide detail tables, but the tables have all the attributes that let you answer questions from any perspective. And it's okay that we've overburdened storage and compute because they're free now. And so, in other words, rather than an aggregated, lossy kind of dimensional fact table, we have a detailed fact table that has all the details for every for what would have been for every aggregate. And now you do the aggregates on the fly because you're just calculating them from the full details. Is that it was a very sort of long-winded way, but is that?
It's literally moving from a world where you're optimizing for analytical capabilities, because that's your bottleneck, and you're moving to a world where you're optimizing for the most accurate depiction of reality. And it's very different. How
expensive, but you're duplicating some. Like there's many attributes where it's no longer what's the normalized, so that you're minimizing duplicates. Now you're like, okay, we put the same attribute in many rows, but now we can ask from any perspective.
We call them context payloads, and the context payloads, if an event happens over time, you will have every record of that event happening over time, and the payload will be loaded with all the rich data metrics required for that given time. And it will repeat itself. It will repeat itself, and that's fine. That's by design.
And then now, like for in-memory, just to be clear, like if we have an in-memory database for analytics, then it's like that too is okay, because then we can scan with super high speed, and it's not that expensive if we get to that point. Like,
and if you look at any modern data warehouse, like tearing through billions of rows, it's a matter of like, it's just a question of how much compute you put. You can have that in milliseconds if you want.
Okay.
It's amazing to see. There's something about seeing a textbook, and then again, those engineers that come and don't believe it, when they see it with their own eyes, there's a moment of truth that happens, and they realize that the age of AI is not just reasoning and LLMs. It's actually overhauling the best practices and how we build these systems.
Okay, that's helpful. Shall we take a deep dive now into what that data model looks like and the process by which you get there?
Totally. So maybe I would start just by stating 2 principles. We'll look at how we build the models, and then sort of we'll actually look at a model once it's built. So two things to know, So if you think of AI, there's 2 things also that change in terms of just how you think about modeling data or just building systems. First of all, in business, most businesses have a tendency to believe my business runs in a unique fashion. In the world of AI, every business runs exactly the same with exceptions. And AI is remarkable. What's really changing everything with AI is if you give it very crisp targets, so you give it inputs and you give it targets, it's extremely good at figuring out how to get to the target. So it's literally like industrializing thinking. So what used to be complicated for human beings, you need a lot of people for a lot of time to do data modeling. AI, if you give it business targets, it's actually able to build the various parts or the various steps to get there. So when we think of modeling at Maxa, so I'm going to put up a little slide here. So the Maxa 4D data modeling step by step, it's actually 6 steps, and it's based on those premises. Every step, we give AI its target, and it actually will move the data from step to step. So step 1 is move your data in a modern data warehouse where you have limited capacity of storage and you have a limited compute. Step 2 is discovery. So essentially you say, I want to model my financials, I want to model my inventory. So we'll ask companies to share with us a few examples. Give me your last 12 months of financial statements. Give me the last inventory for all your products for the last 12 months. Even give me your shipping orders. Give me all the the transactional asset that you have. We give that as targets to our AI assembly line, and it will actually discover in those cryptic tables. So remember that ERP I said with 10,000 tables? Given examples, it tears through those 10,000 tables and starts isolating the various business components that it's looking for. And
okay, but let me interrupt you for a sec, Raphael, because this is like everyone's familiar with, having like super high quality connectors from someone like a Fivetran. How do you go in and identify all these source tables in a way that sort of unburdens like the data engineer from having to navigate, a schema with 10,000 tables?
This is the fun part. You don't need to even be burdened. Just take a snapshot, move 10,000 tables, take the first, let's say, move all the 10,000 tables for this year, or even that company I referred to, they didn't even know internally what those tables were. So we just synced those 10,000 tables into a modern data warehouse. That was it. They didn't have to figure it out. There's 10,000 tables here, 10,000 tables there. We're good to go.
And so you did a replication.
Exactly.
And then I assume there was some sort of maybe fine-tuned post-trained LLM that knows how to navigate the schema to try and find the relevant tables of interest based on the target schema that you've set up.
So one of the key things of Maxa is we believe and have seen the true power of reasoning of LLMs, but it's all about wrapping it with deterministic software so that you actually can align the outcome with what you want and know it's going to hit it every time. So we actually use foundation models. We don't fine-tune them, but we've wrapped it with software that allows them to really, again, target the AI on the outcome you want. It's able to go from its inputs to the targets. It's really good at that. So our software platform is really that deterministic or intelligent software that unleashes or focuses the reasoning power of LLM. So we're not in the business of fine-tuning or building foundation models. We're in the business of wrapping them so that they're production and enterprise grade.
Just to put a fine point on that, the deterministic part is like you're putting scaffolding around the reasoning capability, and you're saying the deterministic part is I want you to identify and make and sort of keep reasoning until you can fill in this deterministic target, and the target is the data model you've created or this business process model. You're telling it to keep trying until it's got this right.
Exactly. And I mean, it's never AI alone. It's man and the machine, or human beings with AI. So AI will get you first shot, I don't know, 70, 80, 85% at max speed. Then a human being will look at it, say, okay, out of my 10,000 tables, you got about 90% right. Let me just help you. I see you're debating on these two things. Let me just help you and guide you. So there's always high iterations at high velocity with, we'll call it human guidance or an operator. So our data engineers are transitioning, and that's the hard mental part. You're moving from a practitioner to an operator.
Oh, so okay. The data engineer becomes the human in the loop for the low confidence part. Like that's like the Tesla autopilot disengagement. Exactly. That's when the data engineer gets involved. Exactly. Okay, and that's interesting.
And that's a conversation that's interesting because it has a lot to do with business. It's usually because the AI is missing some business context, or it's not able to make the difference between two things. But that pops up naturally. And you go back to the business and you say, we're debating on these two definitions. The business will tell you, oh, sir, you're totally right. I completely forgot to tell you how we map SKUs together. Here are rules. Or you're right. I didn't tell you our financial end of years when they were. And yes, we were two systems and they're not on the same years. We forgot to tell you. So it's usually, again, I'll go back to business exceptions. It's usually teasing those exceptions out and then re-inputting the machine. And what's fun is that you don't need to be right first shot. The machine goes so fast that you have a lot of tries before you get to. We tell our customers, you start, we'll get to 80, 90%, and we'll just nicely iterate our way to 100 together.
Okay. So that's Gen AI applied to maybe not the entire data engineering process, but the
modeling.
It's the sourcing and the data engineering together, because you have the target, so it knows how it has to transform the data and it knows how to source it. And so this data engineer there is now only for, as you say, the ones that it can't do with high confidence.
Exactly. It's like in the industrial age, the assembly line. Before it was artisans working together, building great things. Now an assembly line is 6 steps, with every step exactly the same, with workers that have guides. There's every step has a quality measures, as a verifiable metrics, and then anybody can just stop the assembly line, fix something that needs fixing, start the assembly line again, and it's 6 steps. It'll always be 6 steps, and it just moves through. So whether our customers are in banking, whether in the hospitality business, semiconductor manufacturing, hotels, you name it, they're running exactly on the same AI pipeline.
Okay, so and does that take us to the binding step too? Or I mean, I assume it does, but help us walk through that part.
So once you've discovered, instrumented or discovered the various business parts that your business concepts that you need to bring into, the binding is when AI says, okay, I found the concepts, this is where they are. This is the various payloads also. We talked about payloads earlier. This is the data that comes with creating a work order. This is the data that comes with when I create an invoice, update a customer, shipping order, so on and so forth. It will take those discovered data linking and then turn that into a 4D business activity log, which we'll see in 2 seconds in an image of our data model, and turns it into a row. And then whether you have 1, 2, 3 systems, because most companies, they have more than one systems, this is where you start making all system data look alike, because now they're bound to our 4D data model definition, and then that's how you can run it at scale.
Okay, so just to be clear, that by having a very rich target schema, and having an LLM essentially to do most of the routine work of sourcing and then binding, that's how we get to we get to the sourcing and most of the transformation. Just to recap. Okay.
And just to reemphasize also, this is really important. Remember, AI is great at working really fast when you give it a very clear target. So our data model does not change. So if you think of what were data practitioners at the start of a 12-month project, if you ask the data practitioners, could you with 100% confidence give me the end result of your data model? They'll say no. They'll say, well, it depends on what we're building and how we built to it. In the AI era, if you can put a fixed target, which you always know is the same, AI and you give it very clear context and inputs, it will build the scaffolding by itself to get there. And all you need is an operator to help it tease it in the right direction, or sometimes when it's having trouble to decide, it gives it the right answer and move on. So it's a really, really effective data modeling technique.
Okay, so all right, just because we're not going to have a huge amount of time, let's tell us quickly how the harmonization step works, and then what type of metrics you can put on this. And then for those who are still working with traditional BI tools and want, the static dashboards, how you can still serve them with this, data sort of connection and engineering process.
So if you ask anybody that works in finance or even business and you say like, what's your dream system? They would tell you, I want one system where everything is constant, consistent, named properly, and that that aligns with the way we operate. So harmonization is that step where the business will give you in plain business English the rules by which it wants its GL codes aligned, the rule by which it's going to want its historical customers aligned together, the rules by which product definitions have to come together in a product list that it's fine finite. And also, and this is very important, how that evolves over time. Harmonization is a forever problem. You always are changing things. SKUs are being refreshed. New customers are coming in. Your customers have M&A between each other. Business activity changes also. Keeping the data aligned with the way business wants to see it is super important. It's also super important that the rules are not cryptic SQL or business logic that's hand-coded by developers. They're actually expressed in plain business English. That gets you to harmonize is that view where all the data now is aligned with the way the business is thinking about reality today. And then metrics is just the enrichment layer. So again, I want for sort of my work orders, there's maybe performance, there's maybe timesheets for employees, there's all these metrics, there's the yearly revenue, there's maybe safety stock, daily safety stock calculations or thresholds you want, you name it. So this is the ability now, remember, we're in an environment where compute is infinite, storage is infinite. You could have run-of-the-mill basic computations that enrich sort of the model so that later on when you ask the LLM very complicated questions, it actually has facts to go, it doesn't have to reason with, it actually could go grab sort of on a buffet of everything calculated, the facts it needs to reason. Or if it doesn't find them, then it starts reasoning and building those facts on the fly.
So let me ask just one question about the metrics. Are you able to calculate metrics about the processes that traditional BI could not calculate because it doesn't have all the context? In other words, like BI metrics are really snapshots of entities and they're snapshots of events, I think. But it's very hard to piece together the context to give you a business process metric. Maybe you can elaborate on that.
Maybe what I can do is I can just hold that question. I'll just talk about March predictions, and then I'll actually show the data model. And that way it'll give a nice visual to answer exactly your question.
Okay.
So you can deliver with our system the run-of-the-mill BI that you just referred to. We call that March projections. It's literally just rebuilding star schemas that any Power BI, any Tableau, any tool is used to. Now, what you can add to that, and this is maybe I'll flip to our 4D event model, is remember I said, we are modeling business activity across time. So if you look in our data model, the red section here has business context. So you have the various event names like purchase order, good receive, safety stock storage. You got the process that was part of that generation of the data. Then you have governance, because some data, you could tag it as being finance, maybe operations. You got some time, which is a very critical decision. And this to answer your question, what can you model that you can't with star schemas? These two dimensions are part of that. And then you got your fact dimensions and entities, which you typically be expecting. So for instance, you have your event source, where it's coming from, you got your product ID, your location ID, and then you have additional fact and metrics that sort of come as the payload. You got quantities, totals, so on and so forth. But also you have some additional that like calculated metrics like days since last order velocity, supplier on-time performance, that are sort of there in the payload so that when the AI is looking at it, it has also the full context of everything that's relevant for that business activity. What's really interesting is you could also see our model as a massive time series, or the way the business activity unfolds. So you could start asking questions. When was the last time that this activity or this gap in time happened? When was the last time that we had 10 of these this week? When was so you actually can compare. You have the full history of the company that you can sort of bring to bear at any given question. And there's a lot of, some people call it process mining, But it's also, this model allows you to, there's a lot of information between the records, the time between. So we've seen it. They some questions you open-ended questions. Hey, Maxa, what's happening in my business this week that I should know that I don't know? And then you probably the facts will be right. Well, all your revenue, all your on-time performance is all good, but this customer is answering really, really quickly. For some reason, it's used to be, or sometimes it could be payments. Everything is fine, but there's a shift of 15 days in payments for this customer, which technically, if you look at month end, you'd see all the numbers accurate, but you wouldn't realize that there's starting to be lags in activity. And that is part of the model. It's not something you need to compute. It's not something you have to hand to a data science team to go figure out, or a poor analyst that has to cobble together a couple Excel sheets. It's there already calculated, baked into the model.
So when you say calculated, like you modeled and pre-calculated those metrics, but you could also, I assume, dynamically calculate new metrics based on some time series where it hadn't figured out in advance. And maybe this sounds really abstract, but maybe, Alexis, we can go back to some of the questions you were asking. And the idea is you were talking to the data, but it wasn't just the LLM that was doing all the work. You had invoked a bunch of little analytic tools that were like, I think you once described it to me as if you had disaggregated all the app functions in Excel, and that the LLM knew how to invoke those tools to answer these questions. Now that you have data modeled in a way that you can feed it through and ask it from any angle. In other words, you didn't lose all the details in the aggregates, in the traditional aggregates, but now you can ask new questions and calculate new metrics and have the LLM provide a narrative. Maybe elaborate on that.
Absolutely. So back to what Raphael was describing, multiple systems of record become one, let's call it AI system of record, where you do not lose the fine grain from the underlying systems, but all the information gets harmonized at different levels, right? So you've got the aggregates right down to the fine grain, and sometimes the fine grain is more operational in nature and the higher grain is more financial in nature. So that allows you, yes, to pre-calculate a bunch of things, but also if you want to ask a question that involves figuring out the answer on the fly, you want to tap into the reasoning power of the large language models, which is just getting better and better and better by the day. But then the heavy duty calculations, aggregations, computations, you want a lot of that work to be done by deterministic tools. So we give those tools, we have built those tools, we give those tools to the large language models, return the answers, which allows, number one, to be confident in the answer that comes back because we did the calculation. We like to say, we remove some of the sharp objects out of the LLM's hands. We perform that calculation, give the response back. It also allows you to go and be able to trace back the line item records from maybe 7 different systems across 3 continents that contributed to a number. I know whether it's a sales number, a profit margin, a stock count from multiple warehouses whatsoever. So it allows you to really be able to manipulate on the fly the data, having the confidence that the more deterministic calculations are done by tools and the more sort of subjective reasoning capabilities are done by the LLM, including LLMs have incredible business and company and background knowledge, right? So you don't want to kill that. You want to preserve that because they've read typically every book at the library, have attended every MBA class ever done. So you want to preserve that incredible business knowledge so that it contributes to the reasoning process and the understanding of, sometimes the understanding goes into areas you would not expect. For example, it recognizes certain brands. It will know that this is a premium brand. This is more of like a discount store brand. It has all that knowledge because if it's collected all over the internet, but obviously it has not seen your company's private internal data. And we're trying to bridge those two worlds in a responsible way.
Yeah, we've seen that customers pick up on sort of a generic brand and pop out a reasoning where it automatically segmented the generic brands with the high-end brands. And it's not just about running a query and getting the result. It actually looked at the result, said, oh, let me run another query because I need to split. It would be more logical to split this together because their margin profiles, their volumes will be different, and the impact on the business decision making. No-name brand is you are a distributor, you're doing it at scale, and you're not customer facing. So all this logic is more than just number. There's an MBA coming packaged with it.
General business knowledge that was pre-trained into the model, and you're taking advantage of that, but you're now combining with private data and the analytic tools that you know how to invoke. So it's sort of like Perplexity, but where Perplexity is citing like the external web content, you're using a tool and citing the internal business data.
Yeah. And I think you said it well earlier, George, or both of you said it, we're trying to find the best depiction of reality in these massive databases so that when you downstream provide that information to a human or to an AI agent, they actually want to see all the information with the context, right? If I download 100,000 records to Excel, for example, because I want to play around with it, I actually want in those records, like all of the rich information as to what warehouse it came from, what product, what category, the timing elements. That's important for my own human analysis. And the same way that for an AI agent, it really leverages that additional rich context, and it completely abstracts and hides away the cryptic, complex, sort of convoluted databases that are siloed in the 7 systems I was referring to, right? All of that is masked and cleaned up and flattened. So it's nice to see that to a certain extent, humans and AI agents reason in a certain comparable way and require context to actually really be smart.
So let me ask you, where are you in terms of rolling this out with your customers, and how much farther into the user base do you see this type of accessibility making operational and analytic data available? Like, what portion stays on the static, dashboards, and then to what extent can you introduce a new class of users to this interactive way of talking to your data?
So if you think two parts of the answer. So part one, for the last 5 years, right, we've been utilizing technology to unify, harmonize multiple systems of record, allow any form of reporting, dashboarding, etc. So that is not new. That is absolutely battle tested across every vertical industry you can think of, any system you can think of, any number of systems out there. That is absolutely the single best way we have ever found to unify, harmonize multiple systems of record. Now with generative AI in the last kind of 18 to 24 months, you're really heating up on those capabilities, and especially with the advent of the reasoning models, that is the capability that we've pushed out this year in 2025. And we felt that number one, the models weren't exactly where we wanted them to be before that period. We obviously had to build the entire deterministic and software scaffolding around large language models. We've tried them all, tested them all. Some perform better at certain tasks than others. So there's a lot of picking and choosing and reverse engineering how their logic works. So that's what we've pushed out this year, the ability to talk and think with the data, but using the same common trunk or the same foundation of data, which is now in your cloud, in your data cloud of choice, unified, harmonized, and then you can abstract the complexity that's underneath. So that it's really great because we're getting, as we speak, we're getting obviously a few months of feedback from CFOs, FP&A managers, supply chain managers, business analysts, also our friends in data and in IT. And they're using the tool at every end of the spectrum. So for the most simple, like I need just to retrieve a transaction, which is within a certain dollar range. And if I had to explain to you the 94 steps I need to do with IT and this and that to get the data from the SAP system we have running in the UK, that's like a 2-week process. So that's simple use case, right up to questions that are more around, why, explain to me, what do you think is going to happen, where you're really tapping into that subjective reasoning capability, but with all the concrete backup you can get when it's available. So really nice to see that it's actually being utilized across the board. And back to our lawyers, doctors, management consultants, and software developers, like those professionals, top tier white collar knowledge professionals, they have found very creative ways to use generative AI with their practice. And we're just observing the exact same thing with people that deal not with language, but with large databases and big numbers.
Okay,
yeah,
we like to say internally, in the business, specific for business users, the top tier is finance. They have the most rigorous. At the end of the month, the CFO has to say, yes, the numbers are accurate. And if it's good for finance, it's good for everybody.
and so, but is there a way? Do you have yet an idea for how much deeper into the user community, like the ability to talk to your data, extends the need or the desire for data access?
We have some interesting stats around the dashboards, and a lot of public stats, but also our own experience talking to business managers. And like 90% of dashboards oftentimes end up not being used, or behind, every dashboard request, there really was like an ad hoc question that then created a ticket and then a dashboard. But really, the person was looking for one thing. So we realized that this ability to answer ad hoc questions that fall on your desk like 100 times a day is really what this is utilized for, with obviously the ability, as we saw, to generate, beautiful charts and tables and whatnot that you can stick in a PowerPoint 2 minutes after if you have to, download this, have the backup, etc. So this really is a kind of more dynamic ad hoc way of consuming the data is what people are looking for. And analytics is important and needed a significant overhaul. But where this drives us to is more workflow and process automation, because our activity-based, event-based model is also designed so that agents can interact with the data and log, obviously, activity in a very flexible way that is designed, built into the model itself. So obviously, from analytics, the next stop on the bus line is really around automation, workflow, and process, which is, when you look at the back office, I mean, it is littered with such tasks that occupy on value.
And let me push you on that one. Are you saying that now that you have access to the operational detail, and it's not just an analytic aggregate, but you have it from every perspective, are your customers now in a position to operationalize the outcomes or any decisions that come from these much richer analytic perspectives? Does it then become possible to sort of drive a transaction with the underlying system because you have all the relevant context?
I would say there's two things. There's number one, just quality of decision, which we alluded to, which means that with context, we've seen it. The AI is actually able to reason with business knowledge and take good decisions, or at least share up some good decisions or options. But then there's also in the enterprise or in production, what we call enterprise grade, there's also auditability or verifiability. So if you can't make decisions that are verifiable, and you have 10 agents running in parallel, going about your business from month end to inventory to timesheets, if something goes wrong, how do you figure out? How are you auditable? How do you make sure they're working in symphony together? We do not, which is why, again, if you look at what's in production, just with observation skills, there are no agents at scale aside from very, very finite. And this is probably why, is the reasoning capability to reason within a company's context. But more importantly, if they are not aware of the sequences across agents, sort of synchronization, it's almost impossible. So that's what it unlocks.
This is okay. So this is, I mean, and this is our whole thesis, that without this 4D map that goes across all the application silos, it's like self-driving cars that are unaware of all the other self-driving cars and humans. They need that 4D map to have an awareness. So my question then is, do you think, in fact, with agents, this is why it's mostly legal and software development. They don't need to be aware of the state of the rest of the enterprise. But are you seeing then the potential in some of your customers, now that they have a more holistic awareness of the state of the enterprise, the ability to operationalize decisions across silos?
I think one way to look at it is that we always want to bring everything back to dollars. That's why we are obsessed about tapping into the financial system of record at a company. But we also mentioned that oftentimes the fine grain is in operations, right? So if an accountant is trying to spread the revenue according to certain revenue recognition rules, they might need technician timesheets to be able to acknowledge how fast that revenue has been generated. So now you have a financial concept, which quickly becomes an operational concept. So the fact that you can hold in the same model from multiple systems, both the financial impact and the operational levers and the dependency between those two things, that is your path to then being able to change your business and impact the business, because you understand what are the levers that have a financial consequence. So that's always been part of our mantra since day one. But with AI now and with the ability to automate processes, being able to look at both the operational data and the financial data, you can really go and change and optimize your business that way.
Okay. All right. We're going to have to use that as a stopping point. And we're going to say in sometime in 2026, we're going to have to talk to you and see how this technology has helped your customers get so much further down the maturity curve in terms of deploying and leveraging agents. But this was a fascinating discussion about how now that we have LLMs, we have to really rethink. It gives us an opportunity to rethink everything, including how we model the data behind it to really take advantage of it. This was, and you did a great example of explaining why these like dimensional aggregates that we had are a relic of many, many decades ago when we didn't have the compute and storage price performance to compared to today, where we can keep all the detail and we can extract all the context from all the source systems so that we can look at everything from any angle and have a much richer ability to answer questions, not just like what happened from many perspectives, but why and what's likely to happen, and even a little bit of what should happen. So, Alexis, Raphael, thank you for joining, and we look forward to having you back and giving us an update sometime next year.
Definitely. Thank you.
All right. And with that, this is George Gilbert for the Road to Service as Software signing off, and we will see you on a show sometime in the near future. Thanks.